Hello students, how are you? I am fine. I hope you will be fine at your home. Today we are discussing very important compound, that is sulfur dioxide, its preparation, properties and uses. First, let us discuss the preparation of sulfur dioxide. When sulfur burns in presence of oxygen, it will produce sulfur dioxide. Sulfur dioxide gas will be formed by burning of sulfur in presence of oxygen. Second preparation is when sulfide salt, sodium sulfide, potassium sulfide, any sulfide salt, when treated with dilute sulfuric acid, this is dilute sulfuric acid, produce sulfur dioxide gas, and corresponding sulfate will be formed, but the gas is formed, that is sulfur dioxide. Very important. Sulfide, when it reacts with the dilute sulfuric acid, produce sulfur dioxide gas. That is one second preparation of sulfur dioxide. When copper metal is heated in concentrated sulfuric acid, when heated in presence of concentrated sulfuric acid, produce sulfur dioxide gas. This is also one example of laboratory method of preparation of sulfur dioxide. When copper metal reacts with sulfuric acid, then when the solution will be heated, then produce sulfur dioxide gas. Fourth method is when sulfide salt will be roasted at a high temperature. Roasting means heating of the substance, heating of the ore at a high temperature. So when the sulfide ore of iron is heated in presence of oxygen at a high temperature, then it will produce oxide ore. Sulfide is converted to oxide and release sulfur dioxide gas. This is also one important preparation of sulfur dioxide. So sulfur dioxide can be prepared in these four ways. What are the properties of sulfur dioxide? Sulfur dioxide is a colorless gas but pungent smelling and sulfur, producing sulfur smell, pungent smelling, and which is water soluble. Sulfur dioxide gas is water soluble, and when it is dissolved in water, SO2 plus water produce sulfonic acid. This is called sulfonic acid, and this sulfonic acid is acidic character, which is divasic, weak acid, weak divasic. Weak divasic acid, H2SO3 is formed. That's why sulfur dioxide is acidic character. It is dissolved in water and produce sulfonic acid, which is divasic acid. When sulfur dioxide, as it is acidic, it has acidic nature. When it reacts with sodium hydroxide, produce sodium bisulfide salt, or it may produce sodium sulfide salt on further reaction. So it produces bisulfide and sodium sulfide. Both products are formed when it reacts with sodium hydroxide because it is basic. So sulfur dioxide reacts with sodium hydroxide, forming sodium bisulfide and sodium sulfide. But when this sulfur dioxide gas pass through lime water, that is calcium hydroxide, aqueous calcium hydroxide solution, then the solution becomes milky due to formation of calcium sulfide. When excess sulfur dioxide will pass through this milky solution, again the solution becomes colorless due to formation of calcium bisulfite. So this reaction, this nature is similar like carbon dioxide. We know when carbon dioxide pass through lime water it becomes milky. When you pass excess carbon dioxide it become colorless. Same when sulfur dioxide gas, this is also one test of sulfur dioxide. When sulfur dioxide will pass through lime water, first milky solution will form, milky color will form. When more SO2 gas will pass and will produce calcium bisulfite, would become colorless because it is water soluble, and calcium sulfide is water insoluble. This is the nature of, this is one important characteristic of sulfur dioxide. Sulfur dioxide acts as oxidizing agent and also reducing agent. Both sulfur dioxide acts as oxidizing agent and reducing agent. Here, when sulfur dioxide is converted to sulfate ion, then it is oxidized. This is reducing agent character. As sulfur dioxide is oxidized to sulfate ion, this is +4 state. Now this is +6 state. So +4 changes to +6 means it is oxidized. So sulfur dioxide acts as a reducing agent. But when sulfur dioxide +4 changes to 0, that is reduced, so it is oxidizing agent. That means sulfur dioxide acts as both reducing and oxidizing agent. Both. It depends upon the change. When it converts to sulfate ion, it acts as a reducing agent. When converted to sulfur, it acts as oxidizing agent. What are the reducing and oxidizing property of sulfur dioxide? Let us discuss. It converts, it reduces ferric salt to ferrous salt. Ferric ion convert to ferrous ion. You see the change. So ferric plus sulfur dioxide plus water convert to what? Ferrous sulfate. Ferric ion convert to ferrous sulfate. Then you can balance this equation by adding H plus ion in the right side. So here similarly sulfur dioxide reduces chlorine to HCl because chlorine is here 0, now it is -1, so chlorine is reduced to Cl minus, so by sulfur dioxide. So sulfur dioxide here acts as a reducing agent, it reduces chlorine to HCl and itself is oxidized to sulfate. In both cases you see sulfur dioxide convert to sulfate ion, sulfur dioxide convert to sulfate ion, and the reagent chlorine is convert to Cl minus, ferric convert to ferrous, so is a reducing property. Other reducing properties, permanganate ion, pink color of permanganate ion, potassium permanganate reduced to colorless manganese solution. That means sulfur dioxide reduces permanganate ion to manganese ion. Here there is a difference, you will observe some change in color. Here pink color of potassium permanganate change to colorless. This is very important, reducing nature of sulfur dioxide. Here sulfur dioxide reduces permanganate ion to manganese 2 plus, which is colorless. So this is also one important reducing nature. Similarly dichromate ion, potassium dichromate orange color, it will be reduced by sulfur dioxide to green. That means the orange color of potassium dichromate changes to chromium ion, which is green. That is chromium sulfide, which is green in color. That is also one important test of sulfur dioxide. You can test sulfur dioxide in this way. When you pass sulfur dioxide gas to orange color potassium dichromate changes to green color chromium ion. Chromium sulfide is formed, which is green color. Similarly, when you pass sulfur dioxide gas to pink color potassium permanganate solution, the color become colorless due to formation of manganese ion. These are very important reducing property of sulfur dioxide. What are the oxidizing nature of sulfur dioxide? Let us first, again I am repeat this. When it acts as a reducing nature of sulfur dioxide is produce atomic hydrogen. It produce atomic hydrogen. Sulfur dioxide plus water produce sulfuric acid and hydrogen. That hydrogen acts as a reducing character. So what are the oxidizing nature of sulfur dioxide? It oxidizes hydrogen sulfide to sulfur because the hydrogen sulfide is -2. It is -2, now it is 0. So -2, 0 means oxidize. So sulfur dioxide oxidizes hydrogen sulfide to sulfur magnesium to magnesium oxide, because magnesium is oxidized to magnesium oxide. Then stannous to stannic chloride. Stannous chloride convert to stannic chloride by SO2 in presence of HCl as acidic medium. So stannous chloride convert to stannic chloride. Mercurous chloride convert to mercury chloride. There is also, these are the very important, because here stannous chloride is +2, convert to +4, so it is oxidized. Mercurous chloride +1, convert to +2. So this is oxidation of mercurous to mercuric, stannous to stannic. So these are the very important oxidizing property of sulfur dioxide. What are the uses of sulfur dioxide? Sulfur dioxide used as a bleaching agent. It bleaches, it decolorizes color substance. Some vegetables color substance, if a color flower, if you colorful flower will be just come in contact with sulfur dioxide gas, they become colorless. So it decolorizes color substance. This is called bleaching property. Bleaching property of sulfur dioxide is very important, is due to reducing nature. Very important this point. Sulfur dioxide, bleaching property of sulfur dioxide due to reducing nature. Sometimes this type of question is asking in your entrance and also CBSE, that the bleaching property of sulfur dioxide is due to reducing character. Then second uses is preparation of sulfuric acid. We can prepare sulfuric acid from sulfur dioxide gas. And it is also acts as a disinfectant property. Disinfectant property of sulfur dioxide. And also it is used in petroleum, refining of petroleum. In petroleum industries, it is used as a refining. Then liquid sulfur dioxide used as a refrigerant. So these are very important uses of sulfur dioxide. Now let us see how can you balance the equation. Let us discuss this thing. You take this example, that how you will balance the equation. Here MnO4 permanganate ion in presence of acidic medium, sulfur dioxide, it reduces manganese ion and water plus sulfuric acid, sulfate ion. How it will be formed, how it will be balanced, let us discuss. First, you take MnO4 minus, convert to Mn2 plus as per the equation. This is the reactant, this is the product. Now, what is the charge of manganese here? Here the charge of manganese is +7. It is +7. +7. Here is +2. +7 changes to +2. Here you add 5 electrons. Because +7 changes to +2, you add 5 electrons to balance the charge. So +7 convert to +2, here you add 5 electrons. Now, total charge, if you see, here oxygen, 4 oxygen, you add 4 water. Now, here 8 hydrogen, here you add 8 H plus. So this is ion electron method. MnO4 minus changes to Mn2 plus, here you add 5 electron, as 4 oxygen you add 4 water, now it is 8 hydrogen, 8 H plus. Okay, so this is the product of the first step, and this reaction as is addition of electron, this is called your reduction. This is reduction. Then second step here, sulfur dioxide convert to sulfate ion as per the reaction. Here the charge of sulfur is how much? Here the charge of sulfur is +4, here charge of sulfur is +6. So you add 2 electrons. +6, here +4. So add 2 electron. Now 2 oxygen, 4 oxygen, you add 2 water here. Now it is 4 hydrogen, you multiply 4H plus. So now it is balanced. So first equation is reduction, and here second equation is oxidation. So this is your oxidation. Now you add these two equations. Here how many electron? Here 2 electron involved, here also 5 electron. So you multiply 5. Multiply 5. And here multiply 2 to cancel electron. Okay, 5 electron, here 2 electron, 5, 2, that's why you multiply 5 in here and 2 in first one. So you are, now 2 is multiplied, so 2MnO4 minus plus, this is your 5SO2. Then how many H plus, just you see. Here H plus is 16, 2 into 8, 16. But in the right side how much? 20. So right side will be how much? Here 16, here 20, 4H plus will be there. The right side is 4H plus. Then you see Mn2 plus here multiplied by 2. So 2Mn2 plus here sulfate will be 1. So 5 sulfate ion. 5 sulfate ion. So just you see, charge is balanced. You see here how many? 2 negative, here 4 positive, 2 negative. That is multiplied by here 5SO2. Now how many H plus is remain? Here H plus is 8H plus. Here is 8H plus. Here 8H plus, that is 16. Here H plus how much? 20. So 4 water. Water is how much? Just you see. Here water is how much? Here water is 8H2O. Here water is 10H2O. Here is 4 into 2, that is 8H2O. Here is 10H2O. So 2H2O will be here. Now H plus is now 16H plus. Now 20H plus. So 4H plus will be here. 4H plus. Here will be 4H plus. Okay. So 4H plus right side, 2 water in the left side, and 2Mn2 plus, and here 5 sulfate ion and 5SO2, then 2MnO minus. So this is the final your equation, final equation of the what? Net reaction of the reduction of MnO4 minus by sulfur dioxide. That means this is ion electron method to balance the chemical equation. So every equation should be balanced. If you don't balance the equation, then you will lose half mark. So carefully first write the product, then balance the equation. Most of equation can be balanced by ion electron method. So follow this way. Okay. So in this way you can practice some many reaction, how it will balance. Also all reaction you can balance by ion electron method or heat and trial method. Okay. Thank you.